Solving absolute value equations. So now that we've done inequalities, let's bring back in equations, but this time they're going to have absolute value. So the absolute value of x plus 4 equals 9. So just to remind you what absolute value is, absolute value just means distance from 0. X plus 4, the absolute value of equals 9, means that x plus 4 is 9 away from 0. So because it's 9 away from 0, the value of it could be 9, or it could be negative 9, since negative 9 is also 9 away from 0. Now we simplify both of these, and we see that x equals 5, or it could be equal to negative 13, either one. So you see, it's kind of similar there to a compound inequality, where we get two separate answers, and it's either one. That is how these work here. Okay, let's try the absolute value of 2x minus 3 plus 3 equals 18. So the first thing we want to do is get rid of the plus 3 and just isolate the absolute value like that. So now we have the absolute value of 2x minus 3 equals 15. So 2x minus 3 is 15 away from 0. So it could be 15. Or it could be equal to negative 15. Now if we simplify both of these, x equals 9 here. And x equals negative 6 over there. So it's one or the other. If 2x minus 3 equals 15, then x equals 9. If 2x minus 3 equals negative 15, then x equals negative 6. Alright, I think you get the idea, so let's move on to something a little more advanced. Let's put a negative 4x on the other side there. So let's think about this. 3x minus 6 is negative 4x plus 15 away from 0. Now again, if you notice what we did over here is we just take whatever the absolute value is equal to, and it could be either equal to that positive number or that negative number. So we're going to do the same thing here. 3x minus 6 could be equal to negative 4x plus 15, or it could be equal to negative 4x plus 15, but the whole thing negated. So we put a negative sign in front of the whole thing. Like that. Alright, now we have a bit of solving to do here. We get x equals 3 over here. Okay, let's distribute this negative over here so we can solve this a little more easily. Negative times negative 4x is positive 4x. Negative times 15 is negative 15. Negative x equals negative 9. We have a negative in front of both, so x equals 9. Okay, so now we have x equals 3, or x could be equal to 9, either one. Alright, now let's try something with even more stuff in it. Just keep adding more stuff. We're going to put a negative 2 in front of the absolute value, and then subtract 2x plus 11, and set the whole thing equal to 1. Okay, so how do we do this one? Well, first let's just distribute this negative. Just get that out of the way. Okay, just like that. Now, move all of this over to the other side. So this will be negative 2x becomes positive 2x. 1 plus 11 is 12. Okay, now we have a negative 2 in front of this for x minus 5. So that essentially, we can almost pretend the absolute value are like parentheses. Negative 2 is being multiplied by the whole thing here, all this absolute value stuff. So to get rid of it, we divide both sides by negative 2, and we'll get the absolute value of 4x minus 5 equals 2x divided by negative 2 is negative x. 12 divided by negative 2 is negative 6. So now, this is just like a regular absolute value equation like the ones we did over on the left side over here. So, 4x minus 5 could be equal to negative x minus 6, or 4x minus 5 could be equal to negative x minus 6. So since they're both negatives here, they would just change to positives, like that. Over here, 5x equals negative 1 there, sorry. 5x equals negative 6 plus 5, negative 1. X equals negative 1/5. Over here we have 3x equals 11. X equals 11 over 3. So there are our two answers there. It's one or the other. Either negative 1/5 or 11 over 3. Okay, that was a fairly complicated one. So let's do another one like that, where we have a number in front of the absolute value sign. So being multiplied by the whole thing. 4 times absolute value of 8x minus 3 equals negative 3. So divide both sides by 4 to get rid of the 4 in front there. Absolute value of 8x minus 3 equals negative 3 over 4. Okay, so the absolute value of this is negative 3/4. Wait a minute, you notice something a little strange about that. Remember, absolute value is distance from 0, so how can something be negative 3/4 from 0? And the answer is, it can't. There is no solution to this, because the absolute value of anything cannot be equal to a negative number, because there's no such thing as being a negative distance from 0. So remember that. Okay. Let's do another one with no solution so you see how it works. Absolute value of 2x plus 7 minus 2 equals negative 1. Again, absolute value equals a negative number, no solution. Or wait a minute, maybe there is a solution, because remember, you have to have the absolute value isolated by itself in order to see what its distance from 0 is. Up here we had just the 8x minus 3 equal to a negative number. So the first thing we have to do is get rid of this minus 2 by moving it to the other side, making it positive. So negative 1 plus 2 equals 1. Now we actually can solve this. 2x plus 7 equals 1, or 2x plus 7 equals negative 1. And we will get x equals negative 3 over there, or x equals negative 4 over here. So, be careful with that. You have to have the absolute value isolated in order to see what its distance from 0 is, and only if that distance is negative will you have no solution. Otherwise, you can solve it. Okay. One last one. Okay, so again, at first you could say, oh, well, there's no solution because it's equal to a negative number. But remember, you have this minus 8 here that you have to get rid of. And now you can solve this, right? So we're going to divide both sides by negative 3. We're going to get an absolute value of 3x plus 5 equals negative 2 over 3. Okay, and now you see that you thought you could solve it from here, but once you divide both sides by negative 3, this one is actually also unsolvable. Because once you get the absolute value isolated, if it's equal to a negative number, there is no solution. So be very careful to make sure that it's completely isolated. If you have a negative 3 in front of here, you have to take care of all of that first. Okay. That's it for the problems. Just one more thing I want to point out. You may have noticed this. If we go back to here, over here, absolute value of 3x minus 6 equals negative 4x plus 15. Well, it's negative 4x here. How could this be true if this is equal to a negative number? Actually, even if this were, here, let me just write this here. Absolute value of 3x minus 6 equals negative 4x minus 15. This is actually solvable. And you might say, well, how is that? Because you have an absolute value here, completely isolated, equal to a negative 4x and minus 15. Well, the answer is because if you had negative values for x, then this negative 4x would become a positive number. And if that positive number were greater than 15, then this whole thing over here would be positive, and this would be solvable. And by the way, I did check this in advance, and that is actually solvable. So be very careful. If you have negatives over here, but there's an x, then this is still solvable. Okay. So I spent a big deal on what's solvable and what's not there, but that's not all too important because you won't get an unsolvable one all too often. As long as you know the basics of how to solve these absolute value equations, you should be good. Now, in the next video, we'll be bringing back in inequalities and doing absolute value with inequalities. So, go ahead and watch that.